This example comes out of section 5.2, transformations of sinusoidal functions. This example has a few parts to it. First, we're going to be asked to sketch y equals cosine of x plus 30 degrees minus 2. We'll be asked to state the domain and range and describe the transformations from y equals cos x. Even though it was asked in that order, you may want to start by the transformations because I think that might be the easiest part of the problem. Compared to y equals cos x, I would expect a horizontal phase shift of 30 degrees to the left. You could also describe it as a horizontal translation if you like. And I'd expect the whole graph to move down, so vertical displacement down 2 units. I usually find it useful anytime I'm going to transform a cosine function to start off with just a sketch of a cosine function. Hopefully you remember that this thing goes up to 1 and down to minus 1, starts at its maximum, has a period of 360 degrees. I do this in degrees because this question has degrees in it. And if you wanted to draw 2 full cycles, you could say negative 360. Like that. Now we want to take that graph and move it to the left 30 degrees. It may be worth, or will be worth, having a bit better, more accurate set of axes to go from here. So to do my graph, I've made a nice accurate set of x and y axes labeled every 30 degrees, since I want to take my graph and move it to the left 30 degrees. On the initial graph, I have a point at 0, 1. I also have a point at 360, 1, and maybe a useful point here at 180, negative 1. So let's start off just by sketching y equals cos of x plus 30 degrees. Just translate to the left 30 degrees. So the first point that I graphed was 0, 1 is now going to be negative 30, 1, and I have a point here, negative 30, 1. The next point at 180, negative 1 will now be at 150, negative 1. And the one at the far end here was 360, so now it's going to be at 330. So I've got 150, negative 1, and 330, 1. That should allow me to do a half-decent job of sketching one full cycle of this curve. Something very roughly like that. And the graph really just moved to the left 30 degrees. I could draw another, full cycle going to the left. It depends what the question asks, how big a graph I need to draw. As long as you label some points, especially some max and min points, you can show that you know what you're doing, even if the rest of your curve is imperfectly drawn. I'm not a computer, and neither are you, so I don't expect your graphs to be that perfect. But we now want to take this graph and move it down 2 units so that we can say that we've graphed y equals cos of x plus 30 degrees minus 2. So take each of these points and move them down 2 units, which would leave me with a point down here at negative 30, negative 1. This point will move down to 150, negative 3, and this point will move down to 330, negative 1. So let's connect the dots. And I have a final graph drawn here. If I had the ability to do another color here, I would, but maybe I'll put a hashed line across this one so you can tell the difference. But the lowest graph here is what I'm looking at. I've got points labeled showing I know how big or how long or how wide a graph it is. It's followed these transformations of going 30 degrees to the left and down 2 units. Now I need to state the domain and range. Well, the domain is not that interesting because it's still x is an element of all real numbers. The domain hasn't changed. This graph would continue to the right and to the left, as would the other cosine graphs we drew. The range has changed from the original. Normally the y values go from negative 1 to positive 1. Here they're now going from negative 3 up to negative 1. Other than that, all real numbers are fine, but as long as you have the negative 3 to negative 1 component of it, you'd have enough information to show you know what you're talking about. So there's a transformation of a cosine graph going left and down.